Right, in our last video, we looked at how to graph both lines, so our equalities and our inequalities. So those are the ones where we would graph and either just draw the line, or sometimes we would also have to shade above or below it. We are now going to look at how to graph solutions to a system of equations or equalities, and then next we'll look at systems of inequalities. Now a system would be two different equations put together. So anytime you have two different equations, they'll make two different lines, and either those lines can cross at one point, so we'd say there's one solution. I'm going to underline that here. Those lines can be parallel, so there would be no solutions, they would never cross, or they can be the same exact line. They can have two equations that show the same exact line, so there'd be infinite solutions. I'm just going to really quick here draw three different graphs to show you what each of these would look like. Now if we had two equations that looked something like this, these will cross at one point right here, so there'd be one solution. If we had two lines that looked something like this, and they never ever cross each other, there'd be no solutions. There's no spot where those two will cross each other. Now if I had a line that went right here, and then I'm going to draw a blue line that goes right here, notice that these lines are right on top of each other. They're the same exact line. So we'd say the solution is everywhere in the green, which is every single point on here. So we would say there are infinite solutions. So these are the only three possibilities that there can ever be. One solution, if the two lines just cross. No solutions if they are parallel to each other. Infinite solutions if they're the same exact line. So let's see how we would find each of these. In this situation, our first example, we have y equals negative 1/4 x plus 2 and y equals negative x minus 1. Let's graph the first one here using red. We'll start off at positive 2 right here. We're going to go, because it's negative, down 1 and over 4. Down 1 over 4. That means we would also be able to go up 1 and left 4. And I'm going to connect those with a red line. You get the red out. So it would look something like this. So this top one, make this red equation, or this red line right here. We'll do the bottom one in blue then. We start at negative 1 right here. And because it's negative, it's like a negative 1, which is the same as negative 1 over 1, down 1 over 1. So down 1 over 1, down 1 over 1, down 1 over 1, and so on. Which means it does the same in the other direction. Up 1, left 1, up 1, left 1, up 1, left 1, up 1, left 1, right there. So, graphing this one in blue would look something like this. So we have our two equations making two different lines, and we can see that they're going to cross each other right here. Now this spot is the point negative 4, that's our x value, comma 3. That's our y value, 3 up here. What this means is that for both of the equations, if you were to plug in negative 4 for x, your y value would come out to be a 3. So let's try it. What's negative 1/4 of negative 4? Well, 1/4 of negative 4 is negative 1. The negative version of that would be positive 1. So positive 1 plus 2 equals 3. Right there. So this line, this equation definitely crosses that. Let's look at the bottom one. Negative 4, because negative 4 was our x. That would make a positive 4. Positive 4 minus 1 is 3. So that also crosses there. This is the only x and y value, negative 4, 3, that both of these lines will cross through. So we call this the solution to our system. Again, the system is just these two equations. The solution is where they cross, right here. Let's look at this problem. We've got x minus 2y equals 2 and x minus 2y equals 8. Now it's hard to graph these ones, so we want to change them. We'll do the first one first. Subtract x on both sides. Negative 2y equals negative x plus 2. Divide by the negative 2 to get the y alone. Y equals 1/2 x minus 1. Now why did we change it like this? Well, again, now it's in the y equals mx plus b form. We have y alone, m, or the slope, times x, plus our y-intercept right here. So this is going to be our first equation, our blue one. We start at negative 1, We go up 1 over 2, up 1 over 2. Same thing the other direction, down 1 over 2, down 1 over 2. So when we try to connect that with a line, it's going to look something like this. Okay, that is our top equation put into a blue line here. Now let's look at our bottom one. We need to get this in our y equals mx plus b form. Subtract the x from both sides. We get negative 2y equals negative x plus 8. Divide everything by negative 2. Gets rid of that, so we just have y. Negative x is like negative 1 times x. So negative 1 divided by negative 2 becomes positive 1 over positive 2, so 1/2 x. Positive 8 divided by negative 2 is a negative 4. So this is telling us we start at negative 4 right here. We're going up 1 over 2. Up 1 over 2. Same thing in the other direction. Down 1 over 2. Down 1 over 2. And that would go off screen. So we connect all of our points with a red line this time. It's going to look something like that. Notice these two lines are parallel. They are never going to cross each other. So in this case we would say because of that there are no solutions. We know that because these are parallel lines, they will never ever cross. And the solution to a system is where they cross. These don't, so there's no solution. Well, we would say then, if two equations, well, we'll get to this part next. The way to check for no solution is if our slopes are the same. They're both going up 1 over 2, up 1 over 2. Anytime you see the same slope, you know they're either parallel, so there's no solutions, or let's pretend this was not a negative 4, it was a negative 1. That would mean this whole line moves up to negative 1, and it's the same as this line. That would mean that they're the same exact equation, so that would be a situation where you say, if the two equations are the same, then the solution is infinite solutions, because they cross everywhere, or you could just say the same line. Since these have the same slope, but this one is technically, remember, a minus 4, different y-intercepts, it's not that they're infinite solutions, it's that there's no solutions, because they are parallel. So in this case, no solution. If they were the same equation and the same line, that's when you would say infinite solutions. Moving on from those ones, we're going to look at systems of inequalities. We were looking at systems of equations before, so where those two crossed each other and found one exact spot, solutions to inequalities are going to be two shaded regions where both inequalities are true, where they overlap. Now these can have a solution region, or they can have no solution at all, or they can say all real numbers are the place that it works. Everywhere works. So let's see how these ones pan out. Again, we always want to put these into a y equals mx plus b form. These two are both already there. Y equals, in a sense, we're going to pretend that's equals negative 1x plus 2. Top one we'll do is red. The plus 2 means we start right here. The negative in front of the x acts like a negative 1. That means negative 1 over 1. So down 1 over 1, 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 and so on. These are all of the points that that top equation will go through. Okay, that's what the line looks like. Because it has that or equals to, it is going to be a solid line. So we can go ahead and make a solid line for that one. And we know, because it's greater than, we need to find a spot that works. So we're going to double check using our 0, 0 checking spot. 0 is greater than, negative 0 is just 0, plus 2 would be 2. Is 0 greater than 2? No, it is not. So this area is not what works. We need everything on this side. Now we're not going to shade it all quite yet. We're just going to draw, kind of show that with these arrows, this is the area that will work for this equation. We'll get rid of all of this now, and let's try out our bottom equation. We'll do that one in blue. Negative 3 means we start right here. Negative x means, again, negative 1 over 1. So we would go down 1 over 1, down 1 over 1. And same in the other direction. Up 1, left 1, up 1, left 1. because it's the or equals to, we would have to plug it in as a solid line, not a dashed line. And it says less than or equal to, so we need to check. Again, we'll use our 0, 0 mark. Is 0 actually less than? Negative 0 is just 0. Minus 3 is a negative 3. Is 0 less than negative 3? No, it is not, so that's the wrong area. So we're going to shade this spot. Where do these two shadings overlap? If we were to shade all of this and shade all of this, there is no place where these overlap, so we would say this is a case of no solution. If they do not interlap, or should I say overlap, sorry, anywhere, it is no solution. And again, we find it by graphing our line, showing where we'd shade, graphing the line, showing where we shade, and just find where they overlap. Let's try this example then. Again, we'll do the top one in red, bottom one in blue. So we'll just start with the first one right away. This plus 3 means start right here. 1 over 2 means up 1 over 2, up 1 over 2. Same in the other direction. Down 1, left 2, down 1, left 2. Connecting those points. Now again, because this is less than, but not the less than or equal to, we have to use a dashed line. So we will do a red dashed line right there. This is the line we're going to use. We now need to shade, so we're going to check our 0, 0 right here. Is 0 less than, half of 0 is 0, 0 plus 3 is 3. Is 0 less than 3? Yes, it is. So this is the right area. We would shade everything below that line. Let's do our second one then in blue. We've got y is greater than or equal to negative 3/2 x minus 1. The negative 1 tells us to start right here. Minus, or negative 3/2 tells us to go down 3, 1, 2, 3, and over 2, 1, 2. Now we can't really go too much farther with that, so we have to go in the other direction as well. Up 3, 1, 2, 3, and left 2, 1, 2. Right here. So it looks like these two will cross at this point, but that doesn't necessarily mean we want the crossing point. We want to know the whole area where they are the same. So we're going to do one more point, up 1, 2, 3, left 2. We're going to use that then as we make our line, because this is the or equals to. We do have to make a solid line, and we're going to do this one as a solid blue line. So we've got our two lines. We do need to still check where to shade for this one. We're going to use 0, 0 again, right here. Check it for that. Is 0 actually greater than or equal to? Negative 3/2 times 0 is still 0. Minus 1, so we have a negative 1. Is 0 greater than negative 1? Yes, it is. So we shade everywhere above this line. Now I'm going to use the highlighter on here to show you what that should look like. I'm going to do highlighter with yellow. Everywhere below the red line is going to become yellow. So it's going to look something like this. If we were to shade everywhere below the red line. I know this highlighter didn't hit absolutely everything, but we're going to say that it did. Okay. We also need to shade everywhere above this blue line. So I'm going to use a little kind of a blue right here and show you we're shading everywhere above the blue line. When we do that, you can actually physically see where these two cross, or where it makes a totally different color. This green area then is both below the red line and above the blue line. So it's the green area is the solution. Now how you would do this as you're graphing it out, you would just kind of make a darker shaded area. So you'd have your two lines, this one dashed, this one solid. You could do these ones kind of a faded, you know, don't shade these in really dark, and then shade this area really dark. So that it shows very obviously this is the area that both of them are shaded on. So it looks something like this then. So what that's saying is any point in this area will make both of these inequalities true. Let's go on and try this again. We need to first, before we can graph these, turn these into y equals mx plus b forms. This one nor this one are in that form. So on the top one, we subtract 5x from both sides. On the bottom one, we subtract x from both sides. When we do that, it just simply becomes these two equations or inequalities. Now we go ahead and graph those. The top one in red, start at 3, go down 5, 1, 2, 3, 4, 5, and over 1. Now because it is the less than, or sorry, the greater than, but it is not the or equals to, we have to use the dashed line. It'll look something like that. And I'm actually just gonna, oops, grab the, just want the line. We'll go something like that. That'll work. That is the line that we're going to use for the top equation. Check 0, 0 to see if it works. Is 0 greater than negative 5 times 0 is 0, plus 3 is 3. Is 0 greater than 3? No, it is not. So we need to shade everywhere over here. Same thing. We'll do our second line. Y is greater than negative x minus 1. Start at negative 1 right here. Negative x means down 1 over 1, down 1 over 1, down 1 over 1, and so on. Same thing in the other direction. Up 1, left 1, up 1, left 1, up 1, left 1, and so on. Now again, because this is just greater than, not the or equals to, we have to use a dashed line. We'll do a dashed blue line for this one. And we're going to use our 0, 0 to check it. Is 0 greater than negative 0 is 0, minus 1 is negative 1. Is 0 actually greater than negative 1? It is. So we would do everywhere above this line. Now again, like the last one, I could use the highlighter and highlight both of these areas. We could shade this one kind of lightly, this one kind of lightly, and show that this one is really dark. Or if we just make these arrows like we did, we can now see, before we do any extra shading, this area won't work, this area won't work, this area won't work. It's only this area. So we're going to kind of save us some time and not shade everything. We really only need to shade that one area that does work. This area above the blue and above the red is the only spot where all of these numbers, like if I were to pick a random spot right here, this is at x is 3, y is 2. If I plug that into both of these equations, that would be a true statement. If I go to x is 5, y is 1 right here, if I were to plug those into both these equations, it would make a true statement. Everywhere in this area would make a true statement for both of these inequalities. Let's try one more example here. We've got two different inequalities that are not in our regular form. I'm going to do the bottom one first because I just simply subtract x from both sides and now it is there. I'll do the top one up here next. I subtract x from both sides and that gives me negative 3y is greater than or equal to negative x minus 6. Now to get rid of that negative 3, I have to divide by negative 3 on both sides. Now remember, when I do that, I have to flip this inequality sign. Make a note of that. You have to flip the inequality when you multiply or divide by a negative. Now this was like negative 1, so negative 1 divided by negative 3 is positive 1/3. Negative 6 divided by negative 3 is positive 2. So this is my first line. This is my second. We'll go ahead and graph these out. Start here at positive 2. Goes up 1 over 3, and in the same way but the other direction, down 1 over 3. Because it has the or equals to, that means we are going to, we are going to do a solid line with the red. Start over here. It's going to go through those. Now I check with my, my 0, 0. So my check spot is 0. Actually less than or equal to. 1/3 of 0 is 0, plus 2 is 2. Is 0 less than or equal to 2? Yes, it is. So I want everywhere below this line. Now we do the other one. y is greater than negative x minus 2. So I start at negative 2. Start right here. Negative x means down 1 over 1, down 1 over 1, and so on. Also goes in the opposite direction, the other way here. Because there is no or equals to, we would just be using the dashed line. Again, what this is saying is you can't have values that are on this line, but you can have ones that are up to this line. Those will work. We still have to check using 0, 0. So is 0 actually greater than negative 0 is 0, minus 2 is negative 2. Is 0 greater than negative 2? Yes, it is. So this area works. We want everywhere above this blue line. Where is the area that's the same for both of these? It's in between them right here. This is the area we would shade. Now the tricky part about this problem or this example was this part here. Getting the y alone, we had to flip that symbol. So this example just showed us what to do when you flip the symbol. Otherwise, you graph it the same way you would any other one. That'll be our last example then.